We are back here on our lecture for CSE 455 Software Engineering. Uh, this is Wednesday, 15th of April, and we're going to talk about a new chapter today, which is the requirements elicitation. And um, this is the part where you talk with the client and find out what the client wants. And so there is a requirements engineering uh, where the goal is defining the requirements of the software or the system under consideration. And this part of the software lifecycle is where you uh, elicit uh, the um, requirements from the client and uh, from the elicitation process, you come up with the specification. And the specification is written in a document called Software Requirements Specification. Um, how to actually do the software requirements specification. You have seen it in my last lecture that we are using a format on how to write that document. We're going to follow the IEEE standard for writing software requirements specification. And there is another activity called requirements analysis, which is uh, the analysis of the model that the software engineers can unambiguously interpret. Um, this will be part of the requirements analysis next week when we talk about the analysis of the requirements. This is a part where you try to see if the requirements is clear enough and that you have captured all the requirements that the client wants. So let me show you in this diagram here um, what I am talking about. Okay, let me get that diagram out. Okay, so here in the UML diagram, it's called the activity diagram. We see the two parts of the requirements part of the software lifecycle, and we call this the requirements elicitation. And what I said about this is a process of asking the client uh, what are the functional um, needs or the functional requirements of the software. So the functional requirement, if you remember the library system that I use as an example in the UML diagram, what are the functions of the library, uh, let's say to a borrower of the book. Of course, what you want the borrower of the book is to be able to um, search for a particular book. You want the software to be able to extend the loan of the book, and so on and so on. So the functional model uh, represents the the needs of the user from the software. Now there are other non-functional requirements of the software that you need to fulfill, and that refers to um, other um, features of the software that you want to have, like for instance, user friendly. Um, Usability is a non-functional non-functional feature or requirement that you want the software to have. You want the software to be maintained for um, quite a period of time, so you want it to be uh, easily understood. The code should be easily understood and continued for a long period of time or a brief period of time. So both of these are required in the requirements part of the software. So when you interview the client, you will be asking what can the software do for you, and you will also have to elicit from the user the different non-functional requirements that you want, and may not be the client specifying them directly, but based on what the client wants to do with the software uh, through the years, you have to figure out what are the other non-functional requirements that it should have. Okay. Now, analysis is a part of the requirements. Um, we want to be able to analyze that our requirements is well understood, because it is possible that the requirements that you have elicited may be misinterpreted or incomplete. So there must be a way to analyze the requirements that you got. And the analysis could be solved or could be represented by models like dynamic models and analysis object model. Now, from these two UML diagram, you will be able to see what is the uh, what are or what are the requirements that you elicit from the client. Is it complete, or something is missing, or it is misunderstood? And those are important steps in the requirements problem, that everything that you um, elicit from the client is well understood. You don't want to solve or to build a software where the requirements are misinterpreted from the client, because if the requirements is wrong, um, how can you expect to come up with the correct functional software for the client? You cannot build, it's like solving the wrong problem, and the effort you have spent on solving the wrong problem is not going to produce the uh, the right software that the client needs. So we really need to analyze our requirements. It is not enough that I list down the requirements of the software, it is very important that the requirements is well understood. Okay, that's done through analysis. All right. Um, the next diagram is, of course, the UML use case diagram. This is an example in our book where a particular system or software is being built for a web site that actually um, handles um, tournament, and the tournament is going to be um, put out on the web, and people are trying to um, play in the website, and one of the games that the website can offer is like tic-tac-toe game or chess game. And so how do you manage a website uh, that uh, allows the user to play different games and have a tournament among certain group of people to find out who is the winner of the game. So let me close this for now, and uh, and go to the uh, next slide. So the requirements elicitation activity are consist of the following steps. So this part of the requirements is um, if you remember, we um, identify uh, the actors in the use case diagram, and then um, let me go back to where I should be. Um, Sorry about that. Let me uh, and the start. Okay. All right. I lost my cursor. So, uh, okay, we're back here. So, the requirement solicitation activities, if you remember, when this part of the software lifecycle of requirements, you should identify the actors who are going to be the users of the system. Um, then the scenarios, to put out the different scenarios of how it is used. Okay. And then you determine the use case. Use case is the um, uh, functions that the um, software or system provides to a particular actor. And then as you analyze, you refine those use case diagram. Okay. So use case refine, and then you see what are the relationship among the actors and the use case, and then you um, uh, identify the initial analysis objects that you will need, And then you identify non-functional requirements. So going back to the diagram I showed you a while ago, uh, in that game, website game, you want to build a website where people can come and play a particular game. A simple game is tic-tac-toe, for instance. And so there are groups of people who want to play the tic-tac-toe game, play a tournament, and determine the champion among among the different players. So here we identify the different actors of uh, the system called arena. So there is uh, um, there is an operator who is going to run the system. And her name is Alice. So this is more specific rather than operator, just operator. We associate a name, but not necessary that you put a name on the operator. And here is the league owner, the person who owns a particular game, league owner or the league of the tournament. Here is a player. Here is just watching. Some person is watching, and here is an advertiser. So the advertiser wants to put up commercialization uh, ad here in this tournament. So what are the functions the operator wants from the system? Well, he should be able to define the knockout style of the different game. How do they play the tournament? You know, they play a round robin, or they play a sequence of games. Let's say divide into two groups, and the two groups proceed to determine the winner on that group, and then the final winners play against each other. Uh, and the operator can install the tic-tac-toe game there. So the operator defines the uh, the rules of who will be the declared champion of the game, and the game is the tic-tac-toe game. Okay. Then you have the league owner. Uh, he wants to organize the tic-tac-toe tournament. So the league owner, should be able to organize, and this uh, uh, organized is also available to Mary, who is the player, and Bill, who is a spectator. So they can access that one. So this actor just want to watch, and Mary wants to play, and the league owner is the one uh, organizing it. Okay, and the league owner also can sponsor Tic Tac Toe Beginners League, which is also available to the advertiser to do the sponsoring. Okay? And the analysis uh, analyze tic-tac-toe tournament, the spectator can view the analysis of the tic-tac-toe. So it's kind of someone who is watching the game will be able to have discussions about what is a winning situation and what is a draw situation. So this use case diagram describes use cases. Uh, what are the different functions that the software provides, and who are the actors? So it's important that you identify the actors, and then what do they expect from the software as a use case. These are the functional um, uses or functions of the software, and actors uses it, and it has interrelation. The actors interact with the use case, like for instance, the spectator and player, um, and the league owner are accessing the same function called organizing a tic-tac-toe tournament. Okay, so this is a very nice diagram that um, represents uh, actors or users of the or users of the system and use cases. Now the the use case are described in terms of an action word, or it is a verb that defines an action, like define knockout style, install tic-tac-toe game, organize tic-tac-toe, analyze tic-tac-toe tournament, and sponsor a tic-tac-toe beginners league. Okay, so that is a use case diagram that defines the um, that defines the requirements of the software you are um, yeah that you are developing. Okay, all right. So um, I will uh, illustrate later in the next week how to analyze such a requirements specification. Okay. Um, so non-functional requirements are uh, requirements of the system, but not necessarily um, a function that is um, that needed uh, to be implemented. It is a specific. Oh, I lost it again. I'm sorry. Let me get that. I think it is this one here. Non-functional requirements. Okay. All right. Uh, the non-functional requirements has this um, list of um, list of uh, functions that is not nothing to do with the software functionality of what it provides to the actors, but these are um, non-functional requirements that is part of the your development of what it should um, um, have. Uh, One example is the usability. This is usability of what's the level of expertise of the user, uh, and what user interface standards are familiar to the user, and what documentation should be provided to the user. So this is concerned about the ease of using the software. Is it friendly? I used the word user friendly um, a while ago, and um, although this is not a functional requirement, uh, if it is important, like for instance in that tournament or arena example of a tournament of games, um, you want the software to be friendly because the players are probably kids or someone uh, they shouldn't be hampered by um, the non um, non non-friendly uh, um, appearance or the way to find different things on the software that you want to use. So usability is the ease of use of the software, and this has to be part of the software development. You want it to be user friendly, then you should have features or part of the development to make the user interface easy to understand and not complicated. I hate applications where it's hard to figure out how to get to the function that I want, and that is not fulfilling user friendliness. Okay, reliability. Uh, how reliable, available, and robust should the system be? Um, is restarting the system acceptable in the event of a failure? How much data can the system lose? How should the system handle exceptions? Are there safety requirements? Are there security requirements? So reliability is a non-functional requirement that you don't want the software or the system to be crashing all the time, right? You want it to be reliable. You don't want to restart the system and um, you want it to be available. And in spite of wrong input, it shouldn't crash. It should continue operating and used by the user. Performance. We have seen this uh, before, and this is how responsive should the system be. And the example I gave was you shouldn't wait more than 3 seconds um, to see the cursor go back and comes back to the screen and waits for your next command. Okay. Um, are any user tasks time critical that you have to respond quickly? The system, if the user wants, like in a video game, you don't want the system to be very slow in processing the input of a particular player. How many concurrent users should you support? How large is the data store for the system? Does it needs a large data or not? And what is the latency that is acceptable to the user? Okay. Supportability. What are the foreseen extensions to the system later on? Who maintains the system? Are these plans to port the system to different software or hardware? So the some of your projects are um, are porting to the iOS platform, and this software has been implemented in Android. So supportability uh, are the uh, unforeseen or foreseen extensions to the system if it is still being used, okay? uh, or adjustments to hardware environment. Implementation, are these are there constraints on the hardware platform? Are we supposed to be restricted to a certain hardware? Are we constrained by the maintenance team? Let's say the maintenance team has to um, take down the system and maintain it, or are there um, uh, constraints imposed by the uh, testing team? Say, for instance, the testing team has only a short time to test the system because of competition from um, other companies. Are the uh, implementation is uh, constrained by the period or by the time the testing team should finish. Now, interfaces. Should the system interact with existing system? How are data exported, imported into the system? What standards is in use by the client to be supported by the system? So interfacing with other system is very important. And one of the example here of failure of interface is the Obama healthcare. The Obama healthcare for some time, probably a few months, have an interface problem. So the system didn't interface with uh, the the database for doctors. So there was one time the um, the client uh, can't choose the doctor they want because they were not interfaced with the database of doctors completely. So for some time, there was a flaw in the system that uh, you cannot you cannot select the doctor of your choice. Okay. Operation. Who manages running the system? So is the operation 24/7, 365 days a year? Who manages the running of the system? Packaging. Who installs the system? How many installations are foreseen? And are there time constraints on the installation? And that could be a non-functional requirement of the software when we need to package it, and who needs to install the system. Are there legal, uh, functional, non-functional requirements? Should the system be licensed? Any liability issue with system failures? What if it fails? What are our liabilities? And any royalty or licensing fees incurred by using specific algorithms or components. And one of the legal aspect that I ask you to do is to sign a non-disclosure agreement. And there are uh, there are protections of the intellectual property of the software, and that is why it can be copied or it can be just implemented as anybody who wish to develop the software. They should have legal rights on developing the software, and And some of the projects, some of the projects that you are working on has intellectual property, and therefore um, you cannot discuss um, the software outside of this class. Okay, so you are being exposed to the legal aspects of software development. Okay, all right. Now, we're going to talk about sample software requirements documents. And here you will see um, samples of the software requirement specification. So let me um give you uh, a review on the software requirements specification. And we talked about this last Monday. We are following the IEEE standard 830/1998 of the recommended practice for software requirement specification. And I told you that there are three big sections of the IEEE SRS. First, the introduction, then the overall description, and it is important that we give UML diagrams for the system interfaces. What are the system that would interface with our software? And the use case diagram is part of that here. And then the specific requirements, which actually um, um, talks about the functional requirements of your software. What are the functions that it should perform? And also the other requirements, although performance requirements is mentioned here, there are other requirements. We call this the non-functional requirements that the software will have. Okay, so let's look at the. Let me do this again. Uh, in uh, Before we leave the requirements elicitation, um, chapter 4, I'd like to show you a um, a, a formal way of requirements elicitation that is defined by a set of steps that you see here. This is the requirements specification, elicitation um, uh, algorithm that could be followed if you want a formal way of um, eliciting the client for specification. The diagram starts with the project definition, and then the management definition guide is produced. So the oval represents a um, represents a an activity that you should do, and the rectangle represents the uh, represents the output. of the work. And this is called the Joint Application Design, JAD, um, method. The whole algorithm starts with a project definition where they produce a management decision definition guide, and then they do research. So I'm talking about the team of software engineers who are trying to write the software requirement specification. So either they produce a session agenda where the session um, proceeds with the meeting with the client and what are the things to be discussed in the agenda. Or it could produce a preliminary specification, what they think the client wants, and preparation um, activity over here, producing a working document and a session script. So the session script and the session agenda come together and they have a session. The session is a meeting with the client and the software engineers. And there is a form that will be produced, a document called Scribe Forms. And from the Scribe Forms, they prepare the final document, and then out comes the SRS right here, final document. But we don't have the luxury of having requirements engineers. The people that does this is what we call requirements engineers, and they talk with the client to actually produce a final document. What we're going to do in our virtual software company is produce this final document through interviews. And how do you carry that interview? It's up to you. Invite them to Slack so you can talk to them via Slack or email or Zoom. You can have a Zoom meeting with the client and talk to them informally via this method. But just to let you know, there is a formal method of how to elicit requirements spec. Okay? All right. So let me uh, go to the sample SRS. Okay, we have two in the mobile app development website, and this is the first one is the um, Loma Linda University Health Hearts at Home app, and the app is for um, how to take care of children with congenital heart disorder. Here is the list of the team. They are much smaller than the teams that we have now because I have a smaller class. You are big. You are 73 students, and and with the team, there is an additional member called the UI UX designer. I had the luxury of having graphic students join the team, and they help in the user interface, user experience design. Here is the table of contents. As you can see here, it follows the IEEE SRS. There is an introduction section, overall description, and the specific requirements. Okay, so following that format, let's go through the document itself. So the introduction tells us about a background about this project, And uh, the client is mentioned here, Vanessa Ayer Miller of Loma Linda, and uh, and of course telling the reader that this is a work done by the uh, CSE 455 students working with the School of Public Health, Loma Linda University. And there was a winter term. This particular SRS is for second version, a team that follows the previous previous team. So they are continuing work of what was done. So you have to specify a little bit of introduction of what this document is all about. Now, the scope tells us the limitations of what it can do, of what it cannot do. And a previous team has produced the first and second prototype following the agile software development, where we produce the software incrementally, and each incremental development we produce a prototype. So this is what they're going to uh, uh, fulfill in the third prototype, and we will have at least two iterations within the quarter, so that uh, they listed here generally what the third prototype will do, and what the fourth prototype will do. Okay, here are the definitions, acronyms, and abbreviations, the references, all the um, materials you have used in writing this document. And you have um, the following documents listed here. The overview of this document, and the overview is uh, what is the overall, or what is the structure of the rest of the document. And we come now to the second section, which is the overall the product perspective. And here is the system interface. And what we said here is what we specify here is the deployment diagram of the system or software. So the two-dimensional box are hardware, right here, server management, and here is the database. And inside the hardware are the software systems that you are using. Either they are APIs or they are um, code that you have to write. So I have a comment on this diagram here. Um, I wouldn't use this diagram. This is based on an old standard of UML. I would prefer the next example of the how the uh, deployment diagram should look like. But the information is list all the hardware that you will be using, and inside the hardware, what software or APIs will be running. Okay? So my comments here is that it didn't follow the UML notation. That's my comment. But the information that are inside these diagrams are correct. All right, here is the user interface. I told you the user interface section defines or lists all the interfaces that the software will use. And this is a very a detailed picture of all the user interface that you will be using. So each um, uh, block here represents a screen on the mobile app. And this middle box here represents the main page. And the main screen is called the CHD homepage. And what is important are the next screen that will appear after you choose your selection here on the main page. So there is a caregiver support, spiritual needs, about your child's congested heart disorder and treatment, general child care information, tutorials for child care, track your child, and hospital information. So all of these main options lead to other user interface. Okay, and uh, but the main options from the homepage are seven of them. One, two, three, four, five, six, seven. And all the others will be defined in a later um, documentation. All right. So that's all you do in the user interface. List them and define. No drawing of or sketch of the user interface. It will not be shown here. It will be shown in section 3, which is the um, specific requirements. Okay, here are the software that will be used. The memory, my comment here, it didn't mention the minimum memory size that you need. Um, uh, Product function, here is the use case diagram. Here you identify who are the users. Well, here is the user. Actually, this user is the caregiver, and the admin that maintains the software. So what are the functional requirements provided by the software to the user? Well, the user can view the documentation, they can view contact information, they can view and update child's information, view general information, access video tutorials, and access caregiver support. So all of these are verbs or action words that describe what the software can do for this particular user, which is the caregiver. The admin can update documentation, update contact information, update hospital information, and create new links and videos. So that's the boundary of the system, uh, congenital heart disorder mobile app. All right. So this is very important to define the functional requirements of the software. You define the user characteristics, which is usually a parent. What are the constraints for this particular release? Um, Here they are limiting it to Apple devices. What are the assumptions and dependencies you are making? And now we are here in the specific requirements. Now, here in the specific requirements, this is where you show, sketch, or a drawing of the user interface. Now, notice here, there are 1, 2, 3, 4, 5, 6, 7 main menu selection corresponding to the 7 user interface defined in the previous section. And here you will see For the choice general child care information, you have only one choice, library of information. And for choosing tutorials, you have 4 options here. For choosing spiritual needs, you have 2 choices. For hospital information, you have 4 choices. For caregiver support, you have 3 choices. Track your child, 4 choices. And about CHD and treatment, you have 4 choices. All right. So this could be enough for the SRS for now, and it will be updated later on once the other interfaces are defined. And what is important here is you give to the client an idea of what the user interface look like. Then you have hardware interfaces for the IO device, the software interface, um, specifically communication interface with the internet and Wi-Fi. And here are the functional requirements where you define in words what are the uh, different contact page would be the purpose of each of those um, information. Okay. Um, uh, Actually, I would move all of this definition of the screen in section 2, okay, where you define the user interface and their purpose. So my recommendation here is move this section, this entire section of uh, this part here to the uh, user for section 2 on user interface. All right. Now, performance requirements. Here you define the performance of the software, and I define this in terms of seconds. You have to wait to actually take the or give you the next option of the software or to accept your next command. And here are the uh, non-functional uh, non-functional requirement. It must be reliable. It must be available. It must be secure. Okay, and this section here is not part of the format of an IEEE SRS, but the team um, uh, thought it is important to be part of this document. Mm. My own opinion, not necessary. Uh, and the signature as the approval of this document by the client. Here it is. All right. Let's go to the next example of the SRS. Second example, I would say uh, is better than the first one, but I will give you a variety of reasons why I think this second SRS is better. So you see here the theme that was done in spring of 2018. Okay, it's called the optimal state of living. So again, you see the format of the SRS as you can see over here. Introduction, overall description, specific requirements. So following the format of the IEEE. Here is the purpose. Although very brief, I would um, I would expand it some more and tell more about the background of this project. So Amy Wheeler is a faculty in the Department of Kinesiology, and she has an idea of a stress reduction or stress management of people or yeah people who work in the first responder um, kind of work like policemen, firemen, and firefight. I mean first aid responders. So here they define prototype one. What will the prototype one do, and prototype two, what will it do? So prototype one is usually submitted on the 7th week of class, and prototype two is on the finals. So as I said, we follow the agile software development where we produce the software incrementally, and each increment we produce a prototype that is tested and given to the client for evaluation. Here are the list of definitions and acronyms. Reference. Um, this reference rightly reference the IEEE software engineering standard for writing SRS. Since we follow the format, then it is very appropriate that you reference them. And since you are using um, UML diagram, you reference our textbook by Fowler. And I would recommend a reference to a older SRS as your template. And so you're just giving um, acknowledgement that you use a sample SRS for writing this one, right? So overview is the discussion of what's the rest of the document look like. So they talk about second section, what does it cover, and the third section, what does it cover? All right, and then the overall description. Here you see the deployment diagram. So this is I prefer this diagram that you see over here. This is more up to date. The hardware is still a 2D box that you see here. So these are mobile devices, Android. Here is the web server, and here is the database server. Inside the hardware is the software that is running here. So optimal state is running here. And inside the web server are the Firebase server, presentation layer, database interface, uh, authorization interface, and the database server contains the Firebase database. So this component here, component represent either software you are going to write or APIs you're going to use. So they are uh, the symbol for component is a box with two rectangular boxes on this end here. So as I said, this software here could be software that you will have to write, or software or API software that you're going to use. All right, like Firebase API for the Firebase is what you're going to use. All right. Here are the user interface, and it defines user interface for the individual user, the provider. So there are only two that they will provide interface for. What are the software interfaces that you're going to use? Communication, here they talk about HTTP connectivity. Memory, they specify 1 gigabyte of storage and 10 gig download with 100 simultaneous connection. So that to me is very nice to know. Operation, how long it will be operated 24/7. And here is the um, use case diagram. There are two users, the general user, this is the, the fireman, policeman, or military. And here is the provider that provides information or suggested exercises to use. Okay, so taking assessment, access content, view history, edit settings. And so notice here these are all um, verbs or action word. And on the other side, you have add or remove client, view the client, but can access the view history and edit settings. So the edit settings here and this edit settings here are different because the edit settings here for the provider is a general edit settings for all users, while the edit setting here is only for this specific user. So here are the again the functional requirements of the software. You have to extract or elicit this use case from the user, and what are the use cases and who are the actors, users of the system. So you describe what is the user characteristics, what are the constraints that you will have, what are your assumptions that you will have. So the specific requirements talks about user interface, hardware interface, and software interface, and communication interface. So those are defined there. And here are the design of the screen. So they have a logo, and this is the opening page or home page of the mobile app. So this is, I hope you have artists in your team that could draw um, very nice user interface. Here is you're creating an account, you're a new member. Now remember, Optimal mobile app suggests exercises, um, yoga, yoga um, kind of activity to reduce stress from your work. Like, for instance, what we're having today, the health workers are, I think, subjected to the most stressful situation because they're, they are committed to doing their duty to take care of infected COVID-19 patients. But on the other hand, they are scared that they could be infected by the disease itself. And I have um, watched news, and they're beginning to show um, uh, stress from their job and may require psychiatric um, treatment after this pandemic is over. But we should salute and show our gratitude to the healthcare workers. Here is another design of the logo and what the mobile app contain, and exercises that are recommended, your history, your um, uh, the option on the state and the choices of the user changing user settings and so on, and the provider that they are using, they are adding the client, removing client. So this is for the provider managing um, the customers or patients they are taking care of, adding a client and removing a client, and showing all the clients you have and their status. And so we talk about performance requirements and the non-functional requiremements: reliability, maintainability, and portability, and the signature of the client approving your uh, SRS. So um, the SRS is due next week, um, most probably the weekend of next week. So at this point in time, I am really encouraging you to contact your client and talk about the project and the project, since all of you are continuing previous project. You need to ask the client what you want to do this time. And sometimes I think UDROP project may want to start from scratch again. I don't know, but you have to talk to UDROP um, project or a client of what it wants to do. Okay? So I encourage you again to contact your client as soon as possible, probably today, because time is running out. We don't have enough time. This is the second week of class, and next week is again tutorials, getting acquainted with Android and iOS development kit. But you are also contacting your client and producing this document called SRS. All teams um, uh, are required to produce the SRS. I will have another other task assigned to the QA team while you are doing your SRS. Okay, so take care, be safe, and healthy.